Hello and welcome everyone. In this day 17 learning of doubly linked list, we have covered singly linked list and had an introduction in day 15 and day 16. So we are going to be looking at what a doubly linked list would be and what are the different operations and what are the time complexities of each of them. And we are going to use some code snippets that I am going to quickly walk through with JSBin, and also at the end we are going to have a comparative understanding on the singly linked list and its operations, right? Without any hesitation, let's get started. So a doubly linked list would have a previous pointer, data, and a next pointer, right? So let's say we have a value here 5, and it can be pointing to head as per singly linked list, and let's say this one has 12 and this one goes to 38 and this one is null, right? So in case of doubly linked list, there would also be a two-way binding like this, right? So this will have a previous value and also the next value, right? So okay, so this is how doubly linked list would be. And uh, some common operations that we are going to look at is with respect to traversal on a doubly linked list. So traversal, how do we traverse through the doubly linked list? So I will quickly switch between the JSBin editor so that we understand the different operations and come back to this drawing board, right? So yeah, so this is the simple node for a doubly linked list, and as you see, we have head, tail, and length, initially null and null, and we also have a length value for each. So first, traversal of a doubly linked list, we are going to be traversing either in the forward direction or in the backward direction. So this would, both of them would have time complexity of O of n and space complexity would be O of 1, right? So first thing is, let's say we want to traverse from the beginning, then we uh, assign a current pointer with this dot head, and we keep moving till there is the null value which occurs at the end of the doubly linked list, right? So we keep pushing those values, current dot value, and we keep progressing to the next one, and finally we print all of them, right? So yeah, and let me run this also. So here, if you see, uh, if we are moving forward as per this console log here, we have inserted certain elements at the head and two at the tail and one at the middle, but traversal forward would be this way. So as we traverse forward, we iterate 5, 10, 15, 20, and 30. Backward should be this direction. So if you see the backwards part, this dot tail, and we keep going previous. So this is as easy as that, right? And this also would have time complexity of O of n and space complexity O of 1. Okay, so now we have traversal with next and previous, and now let's understand the insertion and deletion operations. Insertion at head and tail and at index or at index, right? Or a position. Okay, so let's look at the insertion operations. So as we have done here, insert head at head, insert at tail, and insert at an index. We are going to look at these operations now. So uh, insert at head, we are going to have a value and check if there is no head, and we assign this new value right after the head and just before the tail. Else we uh, assign this with the head, uh, assign this right after the head this way, and uh, this dot uh, we are just creating swapping. It's just similar to swapping two values between a bucket. Let's say new node dot next is equals to this dot head, and then we finally say this dot new node previous is equals to new node, and this dot head is equals to new node. This is the final operations that we need, but where we do not also want to lose the head value if there was some value associated with head. So we simply uh, initially assign this new node dot next to this dot head, and finally this dot head dot previous is equals to new node, and we simply assign this new node here. It's just like using a three buckets and just swapping those values, right? So, and we also increase the length of the doubly linked list just for our reference. And insert at tail operation. So we check if there is no tail, and we assign this new node, and the similar kind of operation that we had in the head, right? Where we make the new node, and we uh, add we initially set the tail dot next to the new node just as a reference pointer, and then new node dot previous is equals to this dot tail, and finally this dot tail is equals to new node, right? So, and we say this dot length plus plus just to increase the length of the doubly linked list. Okay, so insert at an specific index, we check if the index is less than 0, or if index is greater than the length of the doubly linked list, then we simply return. If is 0, insert at head, and at tail we do this. Else we start at the head and iterate till the specific index, and once we are at the specific index, then we create a new node, and then we swap those values, and finally attach the specific value before the after the specific index that we want the value to be placed, right, with this swapping operation. Okay, and we also increase the length. So this is all that is. Only thing that we need to understand is either this operation here or these set of operations here, right? Just as a swapping between bucket. Okay, so uh, now let me switch back to board. So we have looked at insert head, tail, or at an index, and the traversal, we know that time complexity would be of n and space complexity would be of 1. And in case of this one, the insertion time complexity would be of 1 head or tail, and uh, head would have of 1. We can even have tail also of 1, as we are directly checking the tail and just inserting it there. So space complexity is also of 1, and we do not need any extra space. In case of this one, we might have of n, because we need to iterate to a specific index and then uh, add the specific value. So deletion also should be pretty much similar kind of thing, where we deleted head, tail, or index or position, or by value, index or position, or by value. So these two will again take up a space complexity of O1, time complexity of O1, while a specific index of n and space complexity of one with these two, right? So let's look at these two operations. So delete at head, it's a similar kind of insertion at a specific head. We just cut the specific value saying this dot head dot, we ignore the specific value at the head and we just simply move to the next, and this dot previous is obviously going to be taking up null, and we reduce the value here. And if this dot head dot both are there is no head, then we return. Else if this dot head is equals to this dot tail, then we simply say return is equals to assign it to null and we move out. Deleted tail, same kind of thing. We just say this dot tail is equals to the previous value, just because we are cutting at the end of the doubly linked list, and we say this dot tail dot next is equals to null, right? So this dot, just a little bit of visualization would help us quickly add in all of these piece of functions here. And at a value, we simply uh, iterate till the current value, and then delete at head or tail, and then finally we uh, cut the specific node at a specific index, saying that current dot previous dot next is equals to current dot next, and current dot next dot previous is equals to, we ignore the specific index and move to the next one, and also we join the previous one at a specific index, right? So yeah, this might look a little bit complicated, but once you have the visualization, then that would be a lot more easier for you to understand. Just take your time, just understand or draw out the visualizations, and that should solve. Maybe I will draw out the delete part. The insert part also would be the same, just for us to understand, right? So I'll only go over delete by a specific value. Delete by index is also almost similar, where we uh, get the current pointer at a specific index and then we operate on the current pointer. So for us, let's say delete at a specific value, we take in the value and we uh, iterate the current pointer which starts at head, and run it all the way till current is equals to value. And once we have a match, then we uh, just say current dot next. So this is what we are going to do, as you can see here, right? And we finally remove the values of each of them. Okay. uh, Delete at a specific value, we iterate the current pointer which starts at head, and we check till the value matches, and then we swap the values with the previous and the next pointer, right? So this is how deleted value. Maybe you can also have a small visualization in your head and have all these functions done by yourself, right? Now finally, a few other functions that we can just run past is search for a specific value. If it is there, then we return true, else false. And we have already seen traverse forward and backward. Some utility functions that we have here is size, which we are tracking with the length, and empty with is another useful function parameter here, a function with this class here, and clear, just to clear all the values of this doubly linked list. Okay, so and I am even running this doubly linked list uh, with these input values here, as you see, and time complexity is also I've pasted. So you can refer this code. I will attach the code snippet in our description section of this video. Please go through that and have a mental visualization of how doubly linked list works, and this should help. Now to the final topic. So we are going to be understanding what are some of the key differences when compared to singly linked list. So one of the few major points of comparison is in case of a singly linked list, we have single kind of only forward flow. Here bidirectional flow, and the memory usage in case of a doubly linked list, here we need less memory, as only data and next. This requires previous and data and also next pointer value. So more memory. And traversal, we can traverse both forward and backward. Inserted head or tail is both of one, and deletion of a delete as given node, uh, we can do it in of one time at head and at tail for a given singly linked list or doubly linked list. So in case of reversal, try an operation on how you can reverse uh, singly linked list or even doubly linked list. In case of singly linked list, not possible. In case of doubly linked list, it is possible with previous pointer, no previous pointer, right? So this is one key difference, or this is one key help. So there are two pointers, that is previous high pointer reference is pointer reference only one, next value, next pointer. Here in doubly linked list, two pointers of next and previous, right? So these are the advantages. Even though there is slightly higher memory usage in doubly linked list, we get quite a few advantages of reversing a doubly linked list and also pointer reference, right? So yeah, the single linked list mainly might be used in usage of singly linked list might be such as stacks, queues, right? Uh, Simple graphs also. In case of doubly linked list, bidirectional traversal or bidirectional traversal or efficient operations also, right? So yeah, you can think about the use cases as well. But yeah, these are few pointers that I wanted to put down, just to understand and keep in mind with all the learnings that we have. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.